How do you solve for x in this exponential equation? Pay attention. 9 raised to the power of x plus 4 can be written as follows. 9 to the power of x times 9 to the power of 4 equals. In the same way, 6 to the power of x plus 4 becomes 6 to the power of x times 6 to the power of 4. That's a property of exponents, alright? Now everything with the exponent x, I'll leave on the left side, and everything with the exponent 4, I'll leave on the right side. So I'll repeat here. 9 to the power of x, 6 to the power of x is multiplying, so I move it to the other side dividing. So over 6 to the power of x equals 6 to the power of 4. I'll leave it on this side here. 6 to the power of 4 over 9 to the power of 4. It's multiplying, so I move it to the other side dividing by 9 to the power of 4. Alright? Now pay attention. Since we have the same exponent in the numerator and the denominator of the fraction, we can write this fraction with a single exponent like this. 9 over 6 to the power of x equals, in the same way here, we have the same exponent on top and bottom. So it's 6 over 9 to the 4th power. Notice in this fraction, 9 is on top and 6 is on the bottom, but in the other, 6 is on top and 9 is on the bottom. I'll flip this fraction to match the other. By flipping this fraction, it will be like this. 9 over 6. 9 over 6 raised to x equals, I'll flip it here, 9 over 6. When we flip the fraction, we change the sign of the exponent. If the exponent is positive, it becomes negative 4. Now notice that the bases are the same, and we have an equation, so we can simplify this base with this one. What's left? We're left with x equals 4. Whoever got 4 got the question completely right, okay? Now how do we turn this into mathematical language? First question, the sum of the squares of two numbers. Be careful, because when you read the second one, look, the square of the sum of two numbers. Wow, teacher, isn't it the same thing? Hold on and take it easy. Look closely. The sum of the square of two numbers. In question 1, it asks for the sum of the squares. I'll represent the two numbers as x and y. What are the squares of these numbers? X squared and y squared. Since it asks for the sum of the squares of these two numbers, it's x squared plus y squared. A lot of people will do this here, x plus y squared, and they'll get it wrong. They'll miss the question. Be careful with the interpretation. The sum of the squares is when you take the square of these two numbers and add them, x squared plus y squared, okay? Now look at question number 2, the square of the sum. Now we're going to take the sum of two numbers, so x plus y, and we're going to raise this sum to the power of 2x plus y all squared, which is the square of the sum. This is very different from question 1, which asks for the sum of the squares of two numbers. Did you get the difference? Now, look at question number 3, the triple of the square of a number. Oh, teacher, it's easy when you read question number 4, the square of the triple of a number. Wow, you can't think that these two are the same, number 3 and number 4, but they're totally different. Look, the triple of the square of a number. What is triple? 3 times. So, 3 times the square of a number that I'm going to represent by x. 3 times x squared, which is 3. X squared, okay? It asks for the triple of the square. So you're going to multiply by 3 times x squared. Now, look at 4, the square of the triple of a number. Now, yes, the question is asking for the square of the triple. We're going to take the triple of a number, which is 3x, and we're going to square that. So 3x all squared, which is the square of the triple, different from question 3, which is the triple of the square of a number. Professor, it's very hard to understand. With practice, by solving lots of problems, you'll understand this quickly, alright? The first way to solve it is the way we learn in public school. Remember when you were studying that old distributive trick? Here, you use the distributive property. 6 multiplies x plus 2. So 6 times x is 6x plus 6 times 2 equals 12. All of that equals 30. Plus 12, we move it to the other side of the equation with the inverse operation. So 6x will be equal to 30 minus 12, so 6x equals 18. Moving 6 to the other side, x will be equal to 18. Divided by 6, we conclude that x equals 3. We found the value of x here. This is the way we learn in public school. And in private school, how do we learn? Pay attention. I have 6 times x plus 2 equals 30, the same equation. Isn't the 6 multiplying x plus 2? If it's multiplying, we can move it to the other side by dividing. So x plus 2 will be equal to 30 divided by 6. 30 divided by 6 is 5, right? So x plus 2 will be equal to 5, and then we move the 2 to the other side with the inverse operation. So x will be equal to 5 minus 2. 5 minus 2 is equal to 3. So we conclude that x is equal to 3, the same answer we found before. Ah, teacher. And in the prep course, how do we learn? Calm down, take it easy. If the 6 is multiplying x plus 2, I can eliminate this 6 here by dividing this side of the equation by 6. But everything I do on one side, I have to do on the other side as well. Alright, 6 divided by 6 cancels out, so what's left? X plus 2 equals 30 divided by 6, which is 5 now. Let's eliminate the plus 2 to leave x by itself. Just subtract 2 from this side, but remember to do the same on the other side. Plus 2 cancels with plus 2, leaving x equals 5 minus 2, which is 3 just like before. That's how prep courses teach it, but how is it taught in college? In college, how do we learn this? Well, using logical reasoning, 6 times the quantity x plus 2 equals 36 times what equals 36 times 5. So, what's inside the parentheses has to be equal to 5. In other words, x plus 2 has to be equal to 5. Now, logical reasoning, what number plus 2 equals 5? It's 3. So we conclude that x equals 3. Alright? So, which method did you find easier for solving this? Let me know in the comments. And